and welcome back to Speed Freak Garage, home of power sports on YouTube. So today we're going to be doing our P000012, so that's our 12th official Speed Freak Garage product, which will be our Porsche 944 sending unit cover with integrated grommet for a wire harness, and it will also include the wire harness connector because I just want to do it all as one thing. So the way I'm going to do it is I'm going to cover this. There'll be a grommet right here with a little zip tie post so you can zip tie it airtight and maybe shoot some silicone in there if you want. And then the wire will come up, and in my case I'm just going to zip tie the wire to my cage and run it across, and there's going to be a big junction right here. One part of the junction is for this light, and one part of the junction will be, probably have to pop a hole. I can't do that, the gas tank's in the way, sorry. It'll go up to this hole here, which will go down to the reverse sensor on the transaxle, and then it'll go up to the dashboard and then back to the tail light. So you can see here we did a junction, kind of overdid it a little bit, probably. I mean, I'm trying to make everything redundant. So for example, if something shorts out, then I can unplug this junction. Man, it looks like shit. I need to make improvements on my wiring. But anyway, so that has nothing. Sorry, that has nothing to do with what we're doing here. I digress. So first thing we need to do is find out this hole size, and we're just going to assume that it's round. It would be really dumb if it's not round. So we're going to draw a round circle, and then we're going to try and locate these pins in some sort of way. You would hope they're centered, but they don't look like it. So we're going to draw a square just slightly off center, and the square will have a center point. So the square will have a center point that we're going to try to measure from. So then the diameter of the circle, so the best way to do that is to take your calipers, try to get a nice level measurement. In this case it's going to be a very close, and then you just kind of wiggle it. I mean, you don't want to scratch your paint. This stupid thing's in my way, hold on. Okay, sorry. So you just kind of want to wiggle it until you get your highest measurement, because that's your true diameter. In this case we're looking at 136.59. 136 point. We're gonna go with, so the true value is 136.59. So what that equates to in manufacturing terms is that this hole was probably supposed to be a 137 millimeter hole, and the punch had just worn out. So in order to get the 3D printed part to fit, including the way the 3D printed part shrinks, I'm gonna do 137 for the 3D printed part. And I mean, we can always print as many, it doesn't cost me only but $1 or $2 to print test parts. So, well, I guess if you don't consider my time and electricity and all that fancy shit, if you just, material cost, but that's unfortunately not the whole equation. So now the hard part is going to be figuring out these dimensions, because I want a hole in my cover that the wires can come through, and then there'll be a connector out of a carbon fiber plastic material that holds these specialty bullet connectors in place, and those and it'll like all zip tie together. So, and this is going to be like one of those I look at it top down and hope to God I'm guessing right, and if I'm not, I gotta go and do it over again. So I'm just gonna guess, and you guys have a wide angle lens, so whatever you're seeing, you're not seeing what I'm seeing. 65.48. This is also assuming that these pins are, well, anyway. Okay, and then I'm gonna look at, and obviously if your sending unit is turned a little bit, whatever direction, then this might change a little. So we'll have to have some flexibility somehow in that. But I'm looking at like right there to be 66.59, so that's almost negligible. So 66 times 2 is 132. So it's almost 137. So it's almost dead center, because it's almost dead center in the sending unit. Yeah, so it's damn close. Close enough where we could just make it centered and then compensate with flexibility. Would probably be. Now the other problem is, how does this grommet function and how does it stay in place over use? So the grommet's going to actually have a structure where it'll go like this, and it'll be I haven't decided if I'm going to make it flat topped or have it like so I mean, this is obviously not to scale at all, but so if I do flat top, that's a lot of wasted material. I could do like, you know, I could have it come back down like this and save material, but then in the center here I still need a hole for my connector that I'm gonna manufacture, and then I need a little uptick here with like a spot for a zip tie to sit. I'm gonna make a note for this and a note for this, and the zip tie would just hold everything tight. So problem is I can't even get my calipers down in here, but my guess on this little square here is going to be 25.57. So 25.57. And then a zip tie, I would want to use a larger zip tie, which of course I'm out of black. I would use something like this size, which would be 3 point something, so 4 millimeters, accounting for the shrinkage of the print. And I ordered a little tent for my 3D printer to help with shrinkage problems. It's supposed to be here today, but it'll be here tomorrow. So 4 millimeters there, 25.57 there, and then this. So we need to know how thick this metal is, and then this will probably do. I don't want to. Maybe I'll have to take a look at those keychains we 3D printed, but I think any more than 2 millimeters would be overkill, and then this top piece would probably be, again, 2 millimeters is pretty overkill, but you don't want it to collapse and leak gasoline fumes. So then the thickness of the metal, 1.10, so 1.10. Sorry, I'm going to write my 3D print numbers with millimeter designations. And then the depth, so the maximum depth that the bottom layer can be is going to be pretty small, unfortunately. It's going to be like basically 3 millimeters. I might get away with 4 millimeters. That might be cutting it close. but it shrinks. So I'm gonna we'll start our first prototype with 4 millimeters, top and bottom. We can always tweak it. You can always make the top wider to kind of hold better. I mean, this isn't gonna see any force except for the wire harness kind of moving around. So, see, I'm trying to think what else. So the width between these pins is important, including this alignment post here to keep the connector from spinning. So that'll be square, pin, pin, pin. And that's luckily like that. So we need between those pins, between these pins, and then that one's centered. At least that's obvious. So this is centered. We do need its size though, its diameter. So I can even get my tool in here. It's a 3.45 and it's got these stupid little wings on it. So that'll make it a little harder to work with. They probably go all the way out to, it's hard to tell. It looks like they go out to at least 7 millimeters, if not 8. So I'll probably have like a 10 millimeter slot, just because those wings are in my way. And then from here to here and here to here. So trying to get the distance between the pins is gonna be, you would hope they'd use, you know, even freaking millimeters, but it's Porsche. I'm looking at like so like if I put my instrument on 9 to try and, it's definitely not 9. If I do 8 point, it's very minimal. 8.5, we're gonna go with 8.5. 8.5 millimeters, that's what I'm gonna type into the computer. And then from here to here, 13.5 millimeters. And then, oh, I need a lot of measurements, honestly. And then the edge to edge, that's going to be nearly impossible to get without just plain guessing, because I don't have a good, I should have done this before I installed it on the car, but I didn't really think about it. That's like, could go with 5 millimeters. And then this slot will help with that too. So, and then, wait, what was the diameter of this? I messed that up. This is like 4. So it's 4 millimeters. Okay. And then from here to here, it's gonna be tough. It's gonna be like 9 millimeters. They don't make this easy. Trying to reverse engineer this shit. If I had kept the original connector, it'd be way easier to reverse engineer, but I did not. So, and I think that this is important to have that in there, so we'll see. And I got the pins, I can get that measurements off of these. Because, well, hopefully these work. If these don't work, I gotta go back and look for more. So basically these pins are 3.9 millimeter European bullet connectors. They're the only bullet connectors that have the detent in the female connector. which is just stupid because every other bullet connector I've ever used is the opposite. So there's some kind of specialty connector. And if I put these down, yeah, that's perfect. So Porsche used a 3.9 millimeter European motorcycle bullet connector. And that connector works, yeah, stupid fly, just like this. So, and it doesn't want to come back out, so that tells me I got exactly what I need. Now, as far as the diameter, my thought is that I should use this cover, because the cover is, you know, kind of keeps it clean. And then basically, and the cover's not really cooperating. This might be the wrong one. That might be for the, no, it's not for the bullet. This is, they might not have cut it. Oh, it's because I don't have the wire crimped yet. Okay, let's do this. Let's grab 3 of these. And we're gonna, I think I made ground black. I'll double check on that. But we're gonna grab 3 of these and 3 covers, and we're gonna make a little pigtail. So what that'll do is that'll be zip tied here with a connector, and then the connector will allow the wire to go across, because I'm not sure where I'm gonna ground this. I think you're supposed to ground it to like the closest place possible. So I might ground it, you know, like right here. I mean, I don't see a reason not to, right? Or I could just let the ground run into the wire harness that connects to the dashboard, because then it'll get a better resistance value. Whereas if you ground it to the car only, I mean, you could do both. You know, if you ground it to the car only, you might get a messed up resistance value, and then you won't get good fuel readings. So anyway, we can at least make a, oh crap, that hit the floor. We can at least make our pigtail. Yeah, because they want, if you want to get a used one cut off from a, well, not, I don't know if it's used, but if you want to get an OEM connector, it's like 50 bucks. And if you want to get one of these from Porsche, it's $4 each. I got a box of 250 for $7. So Porsche shit's just a total fucking ripoff. You should never buy from them unless you absolutely have to. And I don't have green wire, so that might be a little issue. Where the fuck's my tape measure? Son of a bitch. Oh, there it is. It's usually up here. Okay, so I want a 1 foot pigtail just for safety here. I got plenty of wire. So right there. And cut. Okay, and then white, although white conflicts with some of the other color scheme, I mean, white's the correct color for the low fuel light. So we're gonna go with white. Where's... Am I missing a color? There's black, brown, what is brown on this? Brown is brake light. I mean, on Porsche, brown is ground, which is, don't get me started. Shit, 1, 2, 3, 4, 5, 6 colors. Did I screw up? I could always make another pigtail with a green. I probably need to order green. I'll have to make a note to order more wire. Especially because I used a lot of orange and black on my trailer, rewiring my trailer. Anyway, so for now we'll just do, I have a lot of extra red. So we'll just do a foot of red. And then for these, they have an insulation crimp and they have a wire crimp, so you don't want to overdo it. In fact, there's very little margin for error on this style. We're going to try the smallest possible. And this wire gauge is probably a little too high for these, because I went with high gauge wire for the car to make sure it never had any issues. So you basically just put your wire and insulation in there, and then I had a crimp. Yeah, here we go. So oh, that's not right. Shit. That's not gonna do shit. I don't have the right crimping tool for this. I might be able to use the weather pack tool if I'm lucky. It's kind of no, I can't. Shit. Yeah, here, I can use this one. Sweet. Okay. That's perfect. Well, sorry, like this. Ah, come on. Come on, little bastard. That did not do shit. Probably because it's not the right size. Yeah, that's not doing shit. Oh boy. Okay, well, at least it crimped the insulation right, but it sure as hell, I think the wire's too thick for the design, so we're gonna have to just kind of mash it, maybe run some solder in there later on, but yeah, we're just gonna have to smash it up. Nope, that's not gonna work. Yeah, that's pretty shitty. Yeah, these aren't for this gauge of wire. Come on. Okay. Yeah, I got it folded over manually with just a little extra wire. Okay. So technically, I guess with all that trouble, I'm only going to make one pigtail then. And so then this, ooh, is this even going to fit this wire? Yes, it will. Just barely. So with this, if I can get the damn thing to scooch up on the... There we go. Okay, so now the bullet connector is properly covered. The insulation's a little far down though, so we're gonna move the insulation. Oh, now it doesn't want to go back. I'm gonna move the insulation back quite a bit. Right there, I think is perfect. Yep. Okay, so we have a nice tight connection now. Obviously, you know, connecting it and disconnecting it is not good for it because it'll loosen up. But so the last part is how is this going to fit into the connector that then holds everything in place and keeps it from getting loose and all that fun stuff. And we want the connector to be nice and tight to keep the connection tight. So basically we have our wire, the insulating ring, and then we have the main bullet connector. And this is a really bad drawing of that, but it's exaggerated. So each one has a diameter that will have to be respected and a length that will have to be respected. Well, that's infinite, but so our goal here is to choose a diameter that will just barely fit. So in this case, 5.93. So we can start with 6 millimeters. Our 3D print will shrink, but 6 millimeters is a good starting point to try. And then for this smaller stage, we're looking at 5.1, so probably 5.5 millimeters. 6 might be too small. And then the wire itself, 3.56 would probably be, oof, that's close. Could do 4 millimeters and tweak. And then the length, so the large part's length, you only want from the brass to the so 12. I'm gonna go with real numbers, 12 millimeters, and then from there to the end of the, could probably do another 12. Well, we wanted to like hold it down, so do like 10 millimeters, and then obviously the rest doesn't matter, so could probably do like 3 millimeters just for strength. Still haven't decided what I'm going to print it out of yet. I have plenty of red ABS. That would be ideal, but I don't know if it's going to print without warping and causing issues. And so that connector would be almost as tall as the grommet, the bottom of the grommet. So basically the moment that we finish the connector, then the connector would need to go through the grommet, and it'll have to contain these wires, which will be basically facing straight up. So what we'll probably do is have a grommet hole the full size of the connector, and have the connector come up through the thing. So basically the connector would be 3 and then plus, I would say 3 millimeters. It would really depend on this. So I'm looking probably a full inch, 24. And the wire would be like guided through that and then zip tied so the wire stays taut and doesn't flail around. And then the ground would probably shoot off. They're going to be, I'll probably do a double ground. So a ground here, just snap a rivet, somewhere here. And then I'm going to do a backup ground like I'm doing, because everything here has a ground. Like this taillight's grounded here with a copper ground. But then it has a backup ground running through the wire harness that will go straight back to the battery. So the whole car will have 2 grounds, the frame ground to the battery and then the wire harness ground to the battery. So it'll be redundant, because grounds are usually the biggest issue with electrical, especially in old ass rusty cars that go through a bunch of water and mud and shit. So anyway, I'm gonna bring this inside so I can test it inside. I can't record video inside, too many noises and distractions, but I can record my screen. So what I'll do is I'll record my screen and do like a 16x or faster time lapse with a little music, and then we'll come back when I'm ready to test out all this stuff. And I'm gonna try to time lapse the printer, but there's no promises, because usually the time lapse comes out looking like shit. But I'm gonna try. So anyway, I'll catch you guys after this time lapse. Okay, so we're back. We've done, I've cut out a lot of video because we had to do 3 revisions of this and 3 revisions of this. So I also did some electrical work off video because it's not really important to this specific purpose. But so basically we got our bullet connectors wired up, and they'll seem kind of loose at first. This is just because they're shitty bullet connectors. That's just how bullet connectors are. So fortunately, this connector I designed will actually kind of compress them and give them a better fit, or a better electrical connection, I should say. So just press this connector down into place, get a nice good fit, and we can test with the multimeter to make sure everything is right. So our ground to white should be 1 ohm. That's good. And then our ground to green is 58, 57 ohms. So that's good. So now what we want to do is run all this through here, and then we need to get this thing installed, which is going to be a pain in the butt because just trying to fit the previous versions was a nightmare. Now this version I made to fit better, so hopefully it fits right, because I don't really want to have to try and do it again. And I printed the seam. There's a seam back here to the rear, well, the rear of the printer, not to the rear of the car obviously. But now the problem is this connector is not perfectly centered, but it's very close, so you can get the connector in place. It should be way closer than last time. Last time it was very far off. This time it should be just about right. If I can just get the last... Okay, so we now have the cover in place with the connector, and so what we're going to do is we're going to push down until they're flush. Make sure that connector is on there, and then I need to get a zip tie and zip tie around it so they kind of, basically they're gonna hold each other in place. So, and I went with red just to go with red. I have black, but what's the fun in that? Now the problem is I don't have any black zip ties left, so I'm just gonna have to, damn, I really want a black zip tie for that. Don't think this is gonna be long enough. Shit. Yeah, but I screwed that up. I need to buy, oh wait, no. I used to have like a whole can of zip ties. I guess I went, ooh, wait. Nope. Crap. Okay. So, yeah, it's just barely not enough. Okay, and this will hopefully hold the connector in place so the connector won't come loose while we're off-roading, because that would not be good. I did not bring all the tools I need, sorry. So we want to make sure these are tight. this TPU. It's gonna be slick, but they sure don't seem to be tightening down very much. There we go. Much better. Okay. Alright, so, okay, and so aside from figuring out where to wire the ground, because I didn't really think ahead on that, so if you're doing this, make your ground wire longer. That's it. The cover works. The connector seems to be working alright. I don't see any issues with it, so it doesn't seem like it wants to go anywhere. So yeah, successful a little bit. Maybe. I don't know. Anyway, thanks for watching, and I'll see you guys next time. Okay, I just wanted to do a quick update. I got all the wiring in place. Looks good enough.